So we should be live now. You can look on YouTube. Ach so, so we need to set up my slides there on the Indico. Yes. What is this QR code for?
This QR code is for the Telegram group so that people can share.
Ah, yes. So I would like that someone verifies on YouTube whether the live stream is working.
Okay. I'll go.
Yes.
Everyone to go to AFY.
What?
Should I tell everyone to go to AFY now to listen to Michael's
Ah,
talk?
one thing is I'm supposed to also give a talk in this room.
Yeah, yeah. But we were just thinking to resume that, like after lunch break.
Ah, yes. So that perhaps we leave this talk out of this conference because we have no time.
No, like we'll manage up the schedule. Like if you wanna give this is an important
Yes,
talk.
yes,
Like if you wanna give
yes.
an
Akashan will find a space for me.
yeah, yeah.
Yes. So that we go to the, which means that we don't need a live stream of the morning of this room.
Yeah, yeah, like we have already tried to, do an online screening, but there's some
Yes,
problems with that.
yes,
So
yes,
that's why we have sent Mikael to L12
yes,
because their online broadcasting is happening. So,
yes. So one thing is, I would like, and only as a test on someone's laptop, perhaps you have one. What? Live stream is working. Is live stream working also for the yes, and one hears the people. Yes. So live stream is working. We know now how to do it. We will not have a talk in the morning session.
Okay.
So I will stop it again. And can you go to the breakout room?
Breakout.
Does it have sound?
I have to charge more. रूम टू के साइड में है ना ये तो L12 हाँ yeah, it may be that they have loaded it right now.
Ah, this is Mikhail's talk. Ah, yeah, then this is working. So, but now one thing is everyone is probably leaving this. Probably I have to pick up.
You start for the lunch. You start up. You start speaking.
I start speaking in this room here now.
Yes. For your
Yes. Then I need then I need someone who helps me to set up the projection. I need someone who helps me to set up the projection because my laptop is now occupied. Yes, my laptop is occupied with the streaming.
Okay.
Hi,
So I'm Sumanta, contacted over you. I'm
from?
a speaker from Fossey Project at IIT Bombay.
Ah, yes,
Yeah.
yes. And when will your talk?
Today evening.
Ah, yes, yes. Nice to meet you.
Yeah.
But I will have to give my talk now,
I see.
and now I need to organize a project. Yes, it's getting live streamed. Yes, but I don't have a projection. I don't have a laptop which projects because they did not organize one.
Mhm.
Hi,
Mohammed.
you are
Mohammed.
Mohammed.
Security officer.
Ah, ah, yes, yes, you look so different in life. Yes, and so yes, it's all scheduled so that yes, especially also I want that when TT Fish is giving a remote talk, that you can be also there. You should be there helping answering the questions. Yes,
Yeah, I see.
yes, for the yes, we need to set up the projection. How do are they doing it now?
So like I don't know you can continue with the talk.
Ah, somebody is doing it. Huh. Somebody is sitting there in the row and doing the projection, or where it is coming from.
Okay.
The projection.
Okay, yeah.
When the projection laptop should perhaps stand here because then I'm in the view of the camera. And if you go to the schedules and to my talk, I've uploaded the slides so that you can download them from there. Yes, yes. You go down and find my talk in the schedules. No, 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 no. Timetable, yes. The yellow one. Yes, yes. What?
PDF or ODP?
PDF. Yes. Yes, and now let's see whether you can make it a full screen so that one does not see the browser. Yes, yes.
ये लगा दे भैया इसको कनेक्ट करो क्या ये
This is not,
सिर्फ नहीं हुआ
hmm. Do you have a USB port?
हाँ हाँ
Yes, yes. Yes.
Now today's computer will be telling us about snap and inventory.
Ah, yes. Hi, everybody. Finally, we have started the live streaming so that anyone outside this nice place also can attend the talks. And so the first talk on the live streaming of this room will be my talk about desktop Linux as easy as a smartphone just in a snap. It is about the universal packaging format Snap, a sandbox distro-independent packaging format. So what the hell are snaps and why should I use them? So not in all the time application developers provide applications, but as source code, and source code cannot simply be used by some consumer who does not know a lot about computing. So one needs somebody who builds the binaries. So one thing is either you bet on the goodwill of distribution developers to make the needed packages RPM or deb, whatever your distro has, or the developer of the software itself, of the application itself, if they want to provide the binaries of the packages, they have the hassle that they have to make individual binaries for 10 or more different distros, and in each distro for 10 or more different versions and test all this. And so this is really a nightmare. And why does one not go the same way as with a smartphone? You can have a smartphone of any brand. Each brand has a certain distribution of Android. And then you go to the Google Play Store and download the apps from the Google Play Store. But these apps, they are only uploaded once. The developers did not create these apps individually for each version of the operating system. And even and Canonical, perhaps somebody of you remembered, they had also tried to make a smartphone. They've created Ubuntu Touch, which is currently continued by the community, and wanted to make and sell a smartphone. But they have abandoned it. But they have learned something from it, because in that time they have also made a packaging format similar to the smartphone's click format. They named it Snap for IoT. They have created an all Snap Ubuntu distribution, and and the Snap packaging format as an IoT platform. So we have Snap already for more than 10 years. The first Ubuntu distro which came with Snap support was 14.04, so 2014. And what exactly is a Snap? Snap is a packaging format for sandbox packaging. This means the app is running in a security cell, which makes it running isolated from the system. And the communication between the app and the system is only going through well-defined interfaces. And we have a Snap store where one can download the snaps, and they have control about whether an interface which is dangerous for the system, where one can really affect the system in a dangerous way, whether this is whether this gets a permit so that it gets automatically connected when one just installs the application. In this way, we have a protection so that we can trust third-party applications and do not need to stay with only trusting our own distros packages, and so being dependent on the package maintainers of our distro, whether a certain software gets available or not. And another thing is our Snap packages. They are not only have not only the security shell, they are operating system distribution independent. A snap package can be installed on any Linux distribution on which one can install snap support. And usually one can install snap support when Linux distribution is running on systemd. And so you have many Linux distributions where where one and the same snap can be installed. And so the developer, the developer of the app makes one snap package from their app, tests it once, and it works on on nearly any operating system. And this works by putting the dependency of the application, the libraries and other auxiliary files into the snap so that it does not depend on the libraries which the host system is providing, and therefore it gets distribution independent. And so you get a user experience like on smartphone apps. And there are several systems which allow you to do distribution independent packaging, but most of the other systems they only support desktop applications. But there are many other kinds of applications from which you would like to have a distribution independent package, which could be daemon system utilities, command line, subsystems, drivers, operate, the operating system core even, and the kernel. All this can get snapped, so packaged as a snap. And this allows to make an all-snap operating system, the mentioned Ubuntu core. And there were already efforts to make even an Ubuntu core desktop with a desktop environment, but currently, at least at Canonical, this part is dormant, unfortunately. And so packaging moves from the distro to the upstream. With a snap format, the upstream can package and it works on all distros. And so the distros do not have the necessity to package certain applications because one can just use the snap, which comes from the upstream project. And so you have 10 or more distros, each one would be packaging a certain package XXX, inventing the wheel again and again. And if upstream xxx.org snaps this application, distros just take the snap. And so the problem is solved. And another thing is when a distro version is released, the distro maintainers do not make new package versions, updated packages of applications for these distro versions. They continue working only on the next version, which is under development. And so if you have a Linux distro and want to have the newest software, you usually have to use always the newest version. And as the newest version come in intervals between half a year and 2 years, when you use Linux distros with classic packages, you have easily packages which are 2 years old. And so when you get the applications as snap, you can always have the newest versions of your applications. And you can keep your distro on which you perhaps have commercial support, which you only get on enterprise distros, which come out every 2 years. And another thing is the snap is more or less an immutable application, as the snap contains a read-only file system with the application's files. And to update the snap is completely updated, completely replaced by the newest version. So you have kind of immutable applications. It's so similar to the immutable distros about everyone is talking nowadays, or at least talk much more before everyone was talking about AI. And so these are snaps. And now we look into the snap packages. What we have is a compressed and GPG signed read-only squash FS image. And this contains all the files which belong to the applications and its dependency so that you can run the application. And it includes also the metadata of the snap, like name and version and things like that in a YAML file. And to install, when a snap is installed, this file system is mounted into the system's file system, and it's accessible also accessible from within the snap security capsule. And inside the snap security capsule, there's also a writable file system so that the snap can have state files and logs and whatever. And the snap itself comes in different types. Most snap are just application snaps, but there can a snap which is the operating system core, which means all the important files in the user space of an operating system, some basic libraries, the basic command line commands, and so. The gadget snap, this is a snap of the boot system, grub and the partitioning scheme of the system which gets booted. Kernel snap, the kernel in a snap, and also a desktop session snap, which means this is a desktop environment. And if you have an Ubuntu core system where you have a desktop session snap on, you get an Ubuntu core desktop. You get a desktop distribution, which is all snap. And to update a snap, it is update as a whole. The immutable file system is completely replaced by the immutable file system of the new version of the snap. But the old version is still kept on the system so that when the new version fails, you can easily roll back to the old one. So you have a backup of the old version. And in the case of a gadget or a kernel snap failing, the rollback is even done automatically. So from the failure, you see only a longer, the boot taking longer, but the system boots and does not get stuck. And to make the downloads of the new snap on an update faster, binary diffs are used so that one makes use that one has the old snap to make the download of the new snap faster. And snap, as I told, is available on multiple distros, practically everything which runs systemd. And it exists already since Ubuntu 14.04, which means April of 2014. So we have a security concept. The first is the read-only file system, which I mentioned, which is also signed. And we have the confinement sandbox, the security capsule, and it uses three security measures of a Linux system. One is AppArmor to secure the file system access. It defines rules how the file system can get accessed. Then there's seccom for restricting system calls, and there are namespaces to have separate spaces of PIDs, users, networks inside the snap and outside the snap. and also between different snaps. And the snap support in the system is the snapd. You install snapd on the system, and then it supports installing snap. It works on systems with systemd as the boot up system, and on Ubuntu, snapd is already installed by default. And snapd is snap confine wrapper program are enforcing the rules and the security capsule. And we snaps are root safe if the application inside the snap is running as root, it is not dangerous for the system, as we have the security capsule of the snap. And so, and especially if you create a daemon snap, a snap of a daemon, which is started automatically on boot, then this daemon is running as root. And also snaps are storage efficient. As the squash file system, or when it is installed, it's just copied onto the host, but not decompressed. The decompression is done online when it's accessed. And then we have also that a snap does not need to contain all its dependencies. There are some snaps which contain common standard libraries, and by not repeating them for every snap, one can save space. It's once the core snap, which contains the operating system core files. These are the basic files as basic libraries, basic commands, uh, and so forth of Ubuntu LTS distributions. And so a snap uses the core snap of the Ubuntu LTS distribution under which it is built. And so this is provided. And another thing is, if you have a snap which needs many libraries, like the GNOME application, you have also content provider snaps. There's a content provider snap for GNOME, for different GNOME versions even, which contains all the common libraries of GNOME, so that not each GNOME application does not need to bring these libraries, which occupy a lot of space. And there are several content providers also for KDE, for FFmpeg, and others. And now I mentioned interfaces for the communication between the host system and the snap itself, the security capsule. And for such communication, the snap connects with an interface. It plugs into an interface of the host system, or sometimes also of another snap. And these are well-defined interfaces. They have rules telling what kind of communication is allowed. For example, they defined exception rules in the up armor to allow these communications. And and examples for interfaces are, for example, network to access the network, cups that you can print, that you have access for printing with cups, dbus so that you can use dbus services, and so on. And there are differentiation. There are so-called safe interfaces and so-called dangerous interfaces. A safe interface does a communication which is merely harmless for the system. For example, the CUPS interface, which allows you to print, but it does not allow you to create or remove print queues or to see somebody else's jobs. Therefore, it is a safe interface. And this means when you download an app which plugs this interface from the Snap Store, this interface is connected automatically and the user can immediately use it. Then there are other interfaces, dangerous interfaces. For example, interfaces will give you system access so that you could format the hard disk, or the CUPS control interface, which allows you to create and remove CUPS queues and to read anybody's jobs. And so this interface is a dangerous interface. And when you create a snap and put it on the Snap Store, and someone downloads it, the interface is not automatically connected. It has to be connected manually, or the Snap developer, the Snap packager, has to apply for permission that the Snap Store permits the automatic connection of the interface. And when they grant this permission, in this case, the interface is connected automatically. And this is the security concept, so that you can trust third-party applications to get installed on your system. And this is very similar to what you find on smartphones. So, and the update mechanism is the so-called atomic update. This means to perform an update, the newly downloaded snap completely replaces the old one. There's no partial update or so, and no possibility to manipulate the files as they are in a read-only file system. So the new snap is downloaded, the new immutable file system is mounted, but the old one is not removed. Also, from the writable file system area, a backup is kept. And so the new immutable file system is mounted at the place where the old was. And so you have done the update, but you have the possibility to roll back to the old one, as we have still the backup of the writable area, and we have still the old immutable file system stored. And as I said, in case of the kernel, the rollback is done automatically. So the next step, Ubuntu Core, the all-snap operating system. So this is very different to other sandbox packaging or distribution independent packaging systems. In the other systems, you could just install desktop applications, but you did not have all the components of your system as a snap. And this is different with Ubuntu Core. It's a system originally created for IoT. And it consists of a gadget snap, which is the bootloader, the partitioning table, and the hardware specifics, and a kernel snap, which is the kernel, the core snap, which is the basic user space files, as I mentioned, of an Ubuntu LTS distribution. With each LTS also there's released a new core snap. And this way you have your operating system, and usually images are published which contain already a complete operating system of all these snaps. So you copy this image onto a storage media and boot the system from the storage media. And so you get the operating system. But once you have done so, you can update each of the snaps individually. So one has so there's a little bit more modularization as on the other immutable file system, as all this on the other immutable distros. On the non-snap based immutable distros, all this is available as one image, and you can replace only this image for an update. And with Ubuntu Core, you have more modularization. And for getting applications on this system, you use snaps from the Snap Store. And here you see everything, all the snaps can get independently updated, and the updates are atomic, so you can do rollbacks. So, and now, what happened with the time of having the snap concept and the Ubuntu Core distribution? It was started to snap, and the case that classic distros like the normal Ubuntu desktop or the normal Ubuntu server, that they support snaps to be installed, snaps of applications to be installed. Many applications got snapped with the primary intention to install them on a standard distro like Ubuntu desktop or so. And then we have many desktop applications in the Snap Store, which would run on normal distros, but would not run on Ubuntu Core. And one came to the idea, why not make Ubuntu Core desktop a desktop version of Ubuntu Core? So we need to add desktop components. And here we see a similar scheme as we have seen for Ubuntu Core. And you see the gadget and the kernel snap, and you see also snapd, which the author of the other scheme did not add. And snapd is also there, and snapd is even by itself a snap, so that it can get updated. And you have the the boot base. This is the core. This is the core file system which I mentioned. This core operating system, the files of the basic files of an Ubuntu LTS distro, and then we have the Ubuntu. Then we have their Ubuntu desktop session snap. The desktop session snap is a snap which contains the graphical display system, typically Wayland, and it contains the desktop environment, which is GNOME, for example, but it could theoretically also contain X and KDE, X and XFCE, and adding such a package, adding such Ubuntu desktop session snap makes a desktop distribution out of Ubuntu Core. And with this, we can install desktop application on Ubuntu Core. And this way, we can use the immutable distro Ubuntu Core as a desktop distro. And the development was started at Canonical, but currently, unfortunately, because they do not have enough people, the development is paused. But everything is open source. You can download everything from the GitHub of Canonical and Ubuntu. And this way, anyone in the community could take on this or make an Ubuntu Core with any desktop they like. And one thing is also, this is a very simple scheme using an Ubuntu desktop session snap. It was actually made in the beginning that way, but I've later on seen the efforts of KDE in a talk in the Ubuntu Summit 2024, and they have split the Ubuntu desktop session snap in smaller pieces, So it's several snaps which make up the desktop. And as always, all the building blocks are snaps by themselves, so they can get individually be updated or replaced by something else. And for the delivery of an Ubuntu core desktop distribution, one uses the components which I've shown in the picture on the slide before, and one includes also the common apps so that you have the same experience as if you would run a normal Ubuntu distro. And one thing is you do not have a command line in that because all it's snapped, you cannot access the system. So for development, you cannot work directly on a bare Ubuntu core system. And what one uses is one uses LXD containers. And in the LXD containers, one has for development, developers use LXD containers on this distro. And in the container, they have an environment of a normal distro where they can muck around with all the files on the system and compile code and so on. And this is the way how you use use the Ubuntu core desktop when you are a developer. And there are many things which have to be worked on. Like for example, when they stopped developing, some things perhaps are already done before they stopped developing. Important is that Ubuntu Core Desktop has NVIDIA driver support. And productivity is also important, like office stuff and so. And for this one needs printer setup tools. And the development of the printer setup tools is going on because this part of the development is done by me by Open Printing upstream or managed by me because I have Google Summer of Code students who work together with KDE and GNOME to update the printer setup tools so that they work also when one has an all-snap distro where one has not complete access to cups, where one cannot install PPD files and printer drivers. And so this work I initiated when there was still work on Ubuntu Core Desktop at Canonical, but it is also needed for Cut 3.x, and so it's generally needed. And so from the open printing side, we are continuing this development. Scanner applications, they are also needed to install scanner drivers on the immutable Ubuntu core. And on this, Akashan Kapoor is working. I don't see him here in the room. So we are missing each other too often. Same last week on the UConn Asia, where I wanted to shout him out. And then for development, more tools would be needed to comfortably develop under Ubuntu Core Desktop. And then one needs naturally TP and full disk encryption, remote manage. And one thing which was planned with Ubuntu Core Desktop is it should be an easy consumer and enterprise distro that you got from Canonical. You could get fleet management via Canonical Landscape, Active Directory login they wanted to do. And if they had turned it into reality, they would have needed distro infrastructure like automation of creating ISOs, testing, stable release tracks, documentation, and so on. But this never turned reality. would mean that if someone from the community want to pick up on the Ubuntu core desktop concept, they would need to do it by themselves, not like with the flavors of the normal Ubuntu, where you get this already from Canonical. And the advantages of an Ubuntu core desktop distro would be once the stability with read-only file system and atomic updates, you do not have all the dependency hell as with normal distros. And this improves security also due to the read-only file systems which cannot be tampered with, and the encapsulation, so that a malware in one app cannot affect the other apps of the system. You can easily exchange modules and do not risk that one affects the other badly and something breaks. And with atomic updates and is everything easily manageable, and privacy is also improved thanks to the encapsulation of the apps between each other. Yes, and this was my introduction into Snap. One thing is, tomorrow morning, I will give a workshop where you can learn packaging applications as a Snap. So that means if you are a developer of an application and want to distribute it easily, you can Snap it. Also, if you see applications which are great and awesome, but not very much commonly used because they do not exist in the Snap Store, you can also Snap them. You can join, for that, you can join also a Snapper community, the so-called Snap Crafters. And one thing is, anyone of you has any questions? Nobody? So then we have completed my talk about Snap. And now anybody has a feeling what it is, and that he can learn a great thing tomorrow in my workshop. Thank you very much. Thank you very much. Avik, how should we go on now?
I think we can break out for the lunch. There is a GSOC panel session, but I don't think we have time now.
Yes, we will find some slots
Yeah,
somewhere
we'll shift it
else.
to the evening.
Yes, so I end the live streaming for the morning.